Hello and welcome to this lesson about two-way frequency tables. The goal of this lesson is to introduce you to what two-way tables are and to kind of go over their anatomy, sort of what goes where and how they all relate to one another. So first of all, let's talk about the definition. Two-way frequency tables are a table displaying data from two variables within one data set. Now that might sound a little bit confusing, so let me try to break that down for you a little bit. The easiest way, in my opinion, to kind of break this down is, let's say we have one set of data, but within it, we're breaking it down into two parts. We have two maybe questions we're asking, two categories we're looking at. And the best way to kind of think about it is we have a this, and then a not this as an option. And then we have a that, not that, as another option. Okay? And so if we were to take a look at the structure of a two-way frequency table, this is what it's going to kind of look like. We're going to make a nice big table. Like this, making a really big bingo board. All right? Now, the parts that matter are here and here. This is where we sort of, quote unquote, define our variables, if you will. And so this is where we say something like this and not this. And then here on the left, we'll go with that and not that. All right? And so with that being said, I think it might help out if we take a look at an actual example. And I think the easiest example for us to kind of use to wrap our minds around this would be a deck of cards. All right? So let me give this a quick shuffle, and we're going to do this live. I have no idea how this is going to work out, but we'll see how it goes. I'm hoping for the best. Now, instead of saying this or that, or sorry, this, not this, what we're going to do is we're going to think about it in terms of maybe like a picture card or a not picture card. And so when I'm talking about a picture card, I'm talking about your jack, your queen, and your king. All right? So we're going to take a bunch of cards and we're going to count. Frequency means how many times something occurs. How many of them are jacks, queens, or kings? Now, instead of saying that, what we're going to do is swap this and we're going to say red. And then we'll say not red. And that works out well because cards come in two colors. They are red or they are black. So let's give this one final shuffle and see how it all breaks down. All right, so what I'm going to do is I'm just going to take the top 12 cards. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Take these cards, put them off to the side. No longer need those. And now let's see what we have here. So I'm going to flip these over. All right, cool. We now have all our cards. Now this is our data set. What we want to do with the two-way frequency table is to put it in here and be able to kind of count some things out. So, for example, let's think about all the red cards right here, all right? So all the red cards have to fit into this top row. We have a grand total of 4 red cards. Now, of them, only one is a picture card. So that's what we're going to do. We're thinking of all just the red cards. We're ignoring all the black cards. We have one face card, one card with a picture. The rest, 1, 2, 3, are not picture cards. And so we've done that. All right, now let me put those away to the side. And let's take a look at all these black cards here. 1, 2, 3, 4, 5, 6, 7 of them are black, but also are not a picture card. And then 1 is a picture card. And so now we've filled out our information. Now here's what's really cool, is that we're going to total these up. So right here, we're going to have a total, and up here, we're going to have a total. All right, now let's see here. How many cards do we have? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. If everything goes well, it should add up to 12. So for example, 1 plus 3 is equal to 4. 1 plus 7 is equal to 8. Here we have the ultimate total, so like total, I'll write this in all capitals, so like the big total of everything, that's 12. Now watch this. 3 plus 7, 10. 1 plus 1, 2. We add those together, we get 12. So we bring it all down together, we have a total of 12. Either way we look at it, if we go from like just this way or if we go that way, put a little plus sign right there. Now, what I want you to take from this is sort of what we're doing is we're overlapping different sets again. So remember, here we're looking at just the picture cards. When it came to the picture cards, we have one that was red and a picture card, and we have one that is black and so not red and a picture card. And then the rest kind of fit into this category right here. So again, a two-way frequency table is a way of displaying data of two different variables, picture, not picture, like picture cards, red cards, and kind of breaking those into even more categories, and then being able to display it so that we can extract some information from it. Now, a couple more things I want to talk to you about before we move on to the next thing. And that is, let's talk about just sort of the anatomy. Again, the structure of this. What I'm going to do is I'm going to put a letter here. P, P, W. When we talk about ratios, we talk about two types of ratios. Part to part, part to whole. And so I just want you to know that, again, this is part, part, whole. You can also go part, part, whole, part, part, whole. Later, when we do more problems with these, it's helpful to know like what's considered to be a part, what's considered to be a whole. That way we can kind of work backwards if we need to, or we could talk about probability perhaps with it. And so I just wanted to show you that as well. Now finally, let me get rid of all these cards. Let's make this interactive. Have some fun. So what I have here is a little check your understanding. Super high tech, I know, be impressed. All right, so what I want you to do, let's see, can I zoom in? I'll zoom in, nice, pro move. I have a set of cards. Now these, I picked it beforehand. One of these matches it, the others don't. So let's take a look at what we have here. So I'm just gonna kind of display it. Oops. So you can see all the cards that we have. It's the same thing. We are looking for reds and blacks, in other words, not reds, and then picture cards, not picture cards. So what I'm going to invite you to do right now is to pause the video, take a look, and see if you can figure it out. In a minute, I'm going to unpause, or we'll, when you're done pausing, we'll go over it and kind of see which one it has to be and which one it can't be. So, pause. 3, 2, 1. Explanation time. All right, let's take a look at it. How many cards do we have? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Well, keep in mind, I said that this spot right here is the total with a capital T, and actually capital everything. Well, one of these doesn't add up to 12. So it cannot be B. It either has to be A or C. Now, we want to start taking a look at some of the other parts. What I'm going to do is take a quick peek right here. I'm noticing that all these match up, which is why it's ultimately 12. So that really won't help me out too much. If I look in terms of, I should have 7 reds, and then I should have 5 blacks. Let's see here. So 1, 2, 3, 4, 5, 6, 7 reds, all right, and then my 5 black cards. So unfortunately, that information doesn't help me out. Now I gotta take a look, and let's take a look at some of the differences. Now, in theory, one of these should be able to kind of eliminate everything for me. What I'm gonna do, I'm gonna zone in now right here. 3 and 2. I'm looking for something that is a picture card and is red. How many of those do I have? Well, just looking at the reds, ignoring all the blacks, I see that I have 2 picture cards. So if it's 2 picture cards, it cannot be this one, and therefore it must be C. C is my correct answer. So hopefully now you have a feel for what these two-way frequency tables are, how they're put together and whatnot. And this is just an introduction, so there's a lot more we'll get into it. But again, hopefully you kind of get what they do and how they work.